Measuring acute angles. Right then, so I'm going to do an example. I'll talk you through what we're going to do as we do it. I'll talk you through some of my logic, so when I measure it, and things I do in order to make sure my angle is like the angle that I measured is likely to be correct. Okay, so I'll start off by drawing an acute angle. Okay, just something like that. That's fine, that'll do. Okay, so first of all, let's have a look at our protractor. So there's two really important parts of your protractor when it comes to measuring angles. Firstly, it's this line going, it starts at 0 on one side, it goes all the way across, and there's a 180 on the other side. So this line here is very important. People often mistake it for the line which is at the bottom of the protractor. It's not that, it's on there, so it's just above it. So when you pull this up to an angle, the angle needs to be on top of the angle. It's not lining up with the edge with the angle, it's on top of the angle. The second key point, as well as this baseline, is this cross here. Okay, some protractors kind of magnify it a bit here so you can be more accurate, but you should be able to see from 90 there's a line that comes straight down and there's a cross. This is where you're going to line your angle up. Okay, so you line one of your edges up with this, your angle up with this. Okay, another thing you've got to pay attention to is where the numbers are starting from, okay? We want to make sure we are measuring from 0 across our angle to read off another answer. Okay, so let's do them steps. First of all, I'm going to take this baseline and line it up with this baseline. So anywhere like this would be fine. Okay, I've purposely done that a bit awkwardly. You'll see that I've lined this baseline up, but I haven't put the cross on the angle or on the vertex. So I'm going to, leaving it in line with that bottom line, I'm going to move it across. So now the point of the angle is on the point on this cross on the compass, on the protractor, sorry. And we have 0 on the inside, which means we're going to be reading the inside numbers. And we're going to go round from 0 upwards. Right, so we've got 10 degrees here, 20 degrees, and you see the big line is in line with 160 and 20 degrees. So it's going to be less than 20. How many notches less? 2. So it's 2 less than 20. This is going to be 18 degrees. Okay, now, before I say that is definitely correct, there's a few things I want to do quickly to check it. Firstly, let's double check our answer is sensible. So we know it is, I'm just going to do a few sketchy lines on here, it's fine. We know it's less than 90, which is good. If I was to split this angle in half, something like that is 45. We know it's less than 45, so we've got a reasonably good idea that this is going to be correct. The reason I say this part, and it's important to be able to estimate angles as well as measure them, is because people often misuse their protractors and they forget to think of their answer in the context of an angle. So say I measured this, and instead of getting 18, I got 162. 162. Now that I've lined that up perfectly, and I could read off the value 162. Okay, but I know from looking at this, it's an acute angle, 162 degrees. It's definitely wrong. Okay, so you need to make sure you're measuring and you're estimating. Okay, estimating is like a quick way of checking that you're likely to be right. Okay, if you are measuring something in a test, because of the thickness of lines and the slight amount of adjustment you can do, they'll normally give it a degree either way. Okay, so on reflection, line the baseline up with one of the lines of your angle, line this cross up with the vertex of your angle, read off, making sure that you start from 0, and then once you've got your answer, look at your angle and think, is that answer sensible? Is this angle, if I was to guess this angle, would I guess something around that? If you are, then you're likely to be correct.